All the SDN technologies have been designed by keeping security in mind. In fact, I feel that SDN is the best way to implement security. And it's just because it makes it very easy. We will get to that into future videos. Anyway, back to the network analysis for SDN migration. First thing we need to do is identify security groups. Since SDN is designed by keeping security in mind, while we are performing analysis on our network, we should look at identifying all the security areas first. At this point, we should keep the thoughts of layer 3 or network layer out of the picture. Just focus from security standpoint. Let's take an example. In this example, you have identified multiple security groups. So like, for example, you have NTP servers, DNS servers, SNMP servers, web, app, DB. And then in your case, you might consider NTP, DNS, as well as SNMP server as part of the same security group because they might have exact same security policies applied to them, and that's fine. Another, in your infrastructure, you might have a firewall or a DMZ network, so that's identified as another security group. At this point, it's also important to identify the networks that you might be connecting to remotely or you might not be managing directly. For example, the internet, let's say the management network or the IT or the desktop network, or maybe some kind of an MPLS network that you're connecting to. So once we are done with identifying security groups, next step is to identify the flows. Now this is very easy to do if you have NetFlow turned on. You will just have very rich data around the flows, what's talking to what, etc. If not, it's okay. You will have to perform the analysis manually or develop some scripts around this. In this stage, we are looking to identify how the security groups we identified communicate with one another. In a typical network, the isolation of security groups would be done using either the ACLs or VRF route leaking, or they will be in completely different VRFs or completely different switches. So in whatever case it might be, at the end of the day, we need to identify how these different security groups talk to one another. So let's take the example that we had last time. So back to this example, we had our different unmanaged networks. We had our firewall or the DMZ network. We had a security group consisting of NTP, DNS, and SNMP, web servers, app, and DB, 3-tier architecture. Now, let's say if you have a DMZ network in between and a firewall, you of course only that particular network will be communicating with the internet. However, there are other areas that will need access to the internet. So this particular group that has NTP, DNS, and SNMP, so probably NTP and DNS servers need access to the internet. So internet will need access to the web servers via this DMZ network. And similarly, management needs access to everything. And probably database servers need MPLS network to do some kind of database replication, and things like that. Like, for example, all these 3 servers need access to NTP. So now at this point, we have a pretty good idea of different security groups, and we also have a pretty good idea of what our different flows look like. Once we have all our workflows identified, we need to identify contracts, contract relationships, and identify our VRFs. This is where we are getting into ACI specific details. In ACI, by default, you need a contract for one security group to talk to another. Yes, you're right, it is a whitelist model. In order to build or identify contracts, our flows will come handy when we created those flow relationships, remember? So let's go back to our example. So in order to enable each of these flows, we need to define a contract. I'm not going to go into the exact details of building a contract. You can look it up on Cisco website. I would like to mention that when we define a contract, there is a provider and there is a consumer. In my experience, if not designed properly, the number of contracts can increase significantly and eventually become unmanageable. In order to avoid this, always take the security group which will be accessed multiple times as the contract provider. So taking a couple of examples here, I've made the management security group and the service security group as the contract providers. So at the end, what this has enabled me to do is I'm creating just two contracts, management contract and service contract for all these connectivities. So like 1, 2, 3, 4, 5, 6, 7, 8. So about 8 connectivities, I'm able to do that in using two contracts. So I don't want to beat a dead horse, but in the end, the only point I'm trying to make is be cognizant of the contracts that you create and try to keep them as few as possible. While we talk about contracts, let us also talk about VRFs. As all of us know, every VRF is its own layer 3 domain. So wherever we have layer 3 boundaries in our network, we should create a VRF in ACI. However, sometimes it might lead into an issue with contracts. Yes, VRF can lead issue with contracts. Let us take an example. In this situation, say you have a VRF which connects you to the internet, and you have a bunch of firewalls which are also connected to the same VRF. As you can imagine, each of this firewall would be its own security group, and internet will be another security group. Now, once you start determining the flows, you might have a full mesh. That is, all the firewalls might need access to the internet, and for some reason, firewall 1 might be needing access to firewall 2, firewall 2 might be needing access to firewall 3, firewall 1 might be needing to talk to firewall 3. So as you can imagine, this entire topology, even though it seems very simple from traditional networking standpoint, gets very complex once you start implementing contracts into this situation. You'll need a bunch of contracts to talk to one another. Adding a new firewall becomes very difficult. So alternatively, what can also be done is make the VRF in unenforced mode. So whenever a VRF in ACI is in unenforced mode, you do not need any contracts. So basically allows all the traffic within that VRF, everything can talk to everything. So this is just a little tip to help improve the architecture and simplify. So once you have identified security groups, the flows, the contracts, VRFs, you are now ready to introduce SDN fabric into your environment and build your use cases. This is where it gets very interesting, and this is the topic of discussion for next couple of videos.